Hi everyone, welcome to video number 9 for chapter 2. This is the last video for the chapter, and in this video we will look at another type of model that's called the transportation model. Now let's take a look at each. So we have two sets of locations. We call them AI for index I, that's one type of location, and another we call BJ with the index J. So we are a transportation company. We need to take goods from location AI and transport them to location BJ. Okay, the same type of goods. And what will be given to us will be the cost to transport from AI to BJ is given. And then the goal now is to find an optimal schedule to minimize the total cost and yet at the same time transport everything from all the AIs to the BJs as required. So to simplify the discussion, let's take a concrete example. Let's assume that I have two locations, A1, A2. There are goods there. Let's say at A1, I have 200 units, and A2, I have 300 units of some goods. Now we need to distribute them to three locations, B1, B2, and B3. And what we need to do is we need to put 100 units in B1, 200 in B2, and 200 units in B3. Okay. So note that here we have the identity A1 plus A2, the total goods in the location A1 and A2 equal to B1 plus B2 plus B3. That's the destination. Okay, so everything is transported and delivered. Okay, now we are given the transportation expenses from AI to BJ. So this is best represented in a table. Okay, so here's the table. What's listed here is from A1 moving to B1, transport this cost me 11 unit of money, whatever. And then this will be from A1 to B2 cost me 12. And transporting from A1 to B3 cost 13. And for A2, we have a similar table. So if you want to transport from A2 to B1, that costs 21 units of your money. And from A2 to B2 is 22. And from A2 transport to B3 costs 23. Okay, so you might have noticed that I just put these numbers in. I can put just any number. It's just for the sake of setting up the model. So here you have noticed I basically collect the indices. 1, 1 is 1, 1, 1, 2 is 1, 2, and then 1, 3 is 1, 3. Okay, so it's easier to remember later on the number. I could just call this cost C11, C12 to be the cost. Okay, but let's have these numbers. Okay, now let's look at setting up a mathematical model. We need to define variables. So we define variables to represent the schedule. So we call variables x with the index I, j. That is the units that I will ship from AI going to BJ. Okay, how many units will I ship there? Okay, and I can list all this information in a table. This will be the following. So from AI, from to BJ, so from A1 move to B1, is x11. From A1 move to B2 is x12 units, and from A1 to B3 is x13 units. Okay, and the second row is totally similar. And now we do have some other constraints. So we know, so these x11, x12, x13 are the goods that's being shipped out of A1. And then I know the total amount of goods in A1 is 200, which means these three must add up to 100. Okay, and the second row is similar. These three are the units of goods shipped from A1. If I add them all up, it should equal to 300 because I will be shipping everything. And then at the same time, we also have destinations. For location B1, B2, B3, I need to ship these amount of goods into it. So what am I shipping into B1? Well, I'm shipping some from A1 and shipping some from A2. If I add these two up, I must have this number. Okay? And so, and to B2, I need to ship 200 units, and to B3, I need to ship 200 units. And these will be our constraint. Let's take a closer look at that. Okay, so the variables are cost function, which will be minimized. So the cost function, we call it f, will depend on all these xi's. Here, actually, we will have 6 of them, right? So x11 is the unit being shipped from A1 to B1. It costs 11 units of money for each, so the total cost is 11 x11. And then you multiply each of these with the corresponding cost per unit, and then you do that, and then you add them all up. Okay, so this becomes your cost. In the setting of our problem, that is the only cost we're considering now. And then we have a lot of constraints, which we already actually talked about, because we need to ship everything and we need to deliver everything. That's a constraint. So we know from the warehouse A1 and A2, we have the constraint. So from A1, all the units being shipped out, these are the 3 being shipped out of A1, must add up to 200. And from A2, the units being shipped out are these 3. If I add them up, I should get 300 because that's what's there. Okay, and then similarly to the destination, we also have constraints. So shipping to B1 are those 2. If I add them up, it need to be 100. And then to B2 is adding these 2 up, it has to equal to 200. And then for B3, adding these up, I must get 200. Okay, so I have these 5 constraints. And then finally, always you have to remember, all the variables are non-negative. I need to put that in. So all 6 of them. Okay, so this is the new model now we have. Cost function to minimize, subject to this constraint that's being listed here. Okay, I want to catch your attention. So here we actually have a new type of constraint. In the past, we have seen constraints less than equal sign and bigger than equal sign. And for this problem, the constraints actually have equal sign. This is also a feasible constraint. Okay, so let's do a summary. So far we have modeled, or we have encountered these problem types. We will need to maximize or minimize a cost or profit function, which is linear or affine, under a set of constraints, and which could consist of several linear equations or inequalities. So it can seem quite overwhelming with so many different types of problems that we have seen. You might be wondering, how do we solve them? Does each of them require a different algorithm and technique? Well, here's a piece of good news. Later on, we will learn that all these types of problems we have seen so far, all of them can be rewritten into in something we call a standard form. So you can rewrite them into a standard form, and then we'll develop solution algorithms just for the standard form. Okay, just stay tuned, it will come later. Okay, so finally, this is a textbook reading assignment. After this video, you should read chapter 2.5, where they talk about another type of modeling. It's called dynamic planning model. Just read it. It's quite nice to read. Okay, so hope you enjoyed the video, and after this one, we will continue our study of chapter 3. Okay, see you then.